Now we're going to hear from Valerio Molinari on measures to evaluate the consequences of climate change on highway maintenance. Valerio, if you can share your screen and take yourself off mute. Thank you.
Thank you, Bob. Good morning, everybody. Speakers, ladies and gentlemen. Just a second. Right. I'm Valerio Molinari, the majority shareholder of Ecogest, the leader company in the sector of maintenance of green areas and drainage systems along highways in Italy. It's a great pleasure that we receive and accept the invitation to take an active part in this workshop. And we hope to be able to provide useful inputs and contribution based on our 15 years of experience. Climate change and its impact on transport infrastructure show how properly adapted maintenance can contribute to the conservation of any transport infrastructure. Maintenance is a fundamental part of an expenditure items determining the annual and multi-annual budget and must include every works, also those often considered residual, such as maintenance of highways drainage system or green areas. When planning and design take place according to correct agronomic and ecological principle, the vegetation preserves the natures of the areas, biodiversity, and reduce management and maintenance requirements. Sorry. The design model used to date are no longer consistent, right, to meet the optimized maintenance cost. A correct programming of green areas, maintenance activities on highways requires target and specialized intervention to derive from a real need for that intervention, also in line with the vegetative development dictated by the constant changing climate. In this two picture, you can see how a correct design of drainage features and landscape integration have an important safety function for the end user. The highway drainage works should also be adapted to climate change. The cutting of properly sized and correctly maintained concrete ditch guarantees the stormwater runoff even in the presence of extraordinary weather events. When we think of soil protection, we must think of a combined effect between a reinforced concrete structure and the surrounding area. There are pressure hydroseeding techniques capable of forming layers with a thickness even up to 3 centimeters, and this technique allows to establish thick and uniform grass cover, and it is often used as an erosion control technique. With what remains, we will plant some trees. This sentence is all too often used when analyzing a project and especially when making an economic offer. Plants must be evaluated not for their cost or for their name, but solely based on their characteristics that must be compatible with the surrounding environment. Native species is the only valid procedure capable of guaranteeing a successful plantation. In this slide, it's easy to notice how a correct and constant maintenance of the green areas allows to guarantee safety, visibility, and the correct use of spaces, without forgetting the aesthetic value of the works create. On the other hand, the lack of adequate maintenance of green areas and slope on areas near bridges and all the structures along highways, but also drainage facilities such as cleaning of ditches, culverts, or road crossing tunnel, lead to a real weakening of infrastructure and needs of the landscape that hosts them. In this picture on the left, it has been necessary to carry out mechanical pruning and filling of plants. Most of them are invasive species, which were growing too close to the road shoulder. In the picture on the right, you can see that the ordinary maintenance was not sufficient and more radical intervention have been adopted. Those interventions required the use of earth-moving machine used to eradicate all the existing vegetation and to rebuild drainage ditches. The cost of this extraordinary intervention exceeding the ordinary maintenance by over 700%. Here, you can see the deleterious impact of invasive species and climbing vegetation on reinforced concrete works, such as bridge or viaduct. The aggressiveness of some of these species on the concrete is one of the main factors that leads to its deterioration. As you can see, this intervention has been carried out on a viaduct pier covered with climbing vegetation. After removing, we could notice that the concrete layers disintegrate, exposing reinforcing bursts and generating an impoverishment of the porosity of the concrete itself. And vegetation maintenance working specification that item weight removal on bridges, viaducts, and overpasses is almost never explicitly mentioned, and the consequences of these technical deficiencies are evident. The lack of control of invasive species growth becoming more and more present also due to climate change can create borderline situation where ordinary maintenance is no longer sufficient to guarantee a current state of conservation of the green areas. Ligustrum lucidium, Rubinia pseudocacia, Alianthus altissima, Acernegundo, and Ambrosia artemisifolia are the 5 invasive species with the greatest impact and the fastest growth, and they can reach dimension and heights over 2 or 3 meters. They may cause the outcome of a new respiratory infection that might be able to interact negatively on existing respiratory disease to the detriment of the public health. Therefore, they deserve to be included in maintenance program as elements requiring primary control. I wish to thank you for the opportunity you gave us and for your attention. However, I think that nothing better than Cassandra project that you are now going to see in a sort of world premiere can make a concrete and visual sense of how the impact on any infrastructure can change its condition and duration in relation to the maintenance techniques and choices. For the reason, I give you now the floor to the architect Mark Canata, with together to the architect Antonio Stornello, has developed in collaboration with Ecogest a new mathematical and computer model whose peculiarity is the possibility of being able to be applied on a parametric basis to every infrastructure and every part of it. No.
Thank you, Valerio, and for the introduction, and good afternoon, everybody. My name is Mark Canata. I am an architect. I'm the CEO of Cassandra. At Cassandra, we're developing an integrated decision support system that facilitates the creation, development, and management of cities to make them more resilient to climate change and improve budgeting and efficiency. We look at the built environment as an ecosystem, taking the whole system view via the analysis of a relational database and the creation of scenarios based on building information modeling and information from sensors. At the basis of Cassandra are parameters directly or indirectly linked to measurable data or accepted quality of life indexes. The top 12 parameters, as shown in the image, contain in turn a large number of subparameters. Each one of these, such as the infrastructure one we're concentrating on today, is given a resilience index that contributes to the overall score of the built environment asset considered, whether it's a city, a landscape, or as we'll see in this presentation, a stretch of motorway. Cassandra can in fact be applied to multiple environments. Amongst other, we're currently undertaking a pilot study for a historic city in Italy, a project in collaboration with a UK university to manage the effects of extreme weather in the Caribbean, and another one for a heritage body in England looking at the future management of historic waterways. But today we would like to talk to you about the pilot study we are undertaking with Ecogest in Italy. The motorway we're focusing on is the A7 that leads south from Milan towards the port city of Genoa, crossing one of the most densely populated and polluted areas of Italy, an area that is likely to be even more prone in the future to higher temperatures and extreme weather events, such as destructive storms, due to the effect of climate change. We are looking generally at urban motorways, or those high-volume roadways that cross areas on the outskirts of cities that are often characterized by proximity of commercial or residential buildings, low-quality verge vegetation, agricultural land, and pockets of residual natural landscape. If we look in detail at a 100-meter stretch of this motorway, we can see how each element contributes to the overall resilience index. And importantly, how each element has an effect on the resilience index of other elements. Clearly, all these elements are interconnected and impact on other parameters such as air quality, water management, and safety. The combined result in this case is an unsatisfactory overall resilience index of 30%. So at this point, having established a baseline with the existing condition, we can then proceed to create various scenarios to increase the resilience of the asset, whilst balancing it with cost, verifying, for instance, what the effect might be if the road surface was changed to one that improves drainage, which in turn improves safety, or one that has increased solar reflection index. And what if we added more curved drainage points and connected these with rain gardens, which allows us in turn to consider different types of vegetation, such as bushes and high CO2 absorbing trees that reduce the maintenance load and costs, improve air quality, and importantly, can dramatically increase local biodiversity. Similarly, the combined impact of increasing the solar reflection index for the road surface would reduce the heat absorption in the area. It is this interconnectedness and whole system improvement that exponentially increases the resilience of an environment such as this one. And imagine what the effect of individual changes such as these could have when rolled along the 100 kilometers of the A7 motorway, where the verge area, if considered altogether, is a green area equivalent to Central Park. And if you consider doing the same for the entire European motorway network, you would have a linear park the size of Delaware. Or indeed, if you looked at the US highway network, you could have potentially an area, a green area the size of Connecticut. So potentially a green biodiverse area larger than Yosemite and Yellowstone put together. So taking a whole system view and considering the combined effect can significantly improve planning, resource management, efficiency, and cost. And at the same time, it allows for enhanced natural and built environment and improving the quality of life of users and inhabitants. Cassandra allows for the opportunity to acquire a large quantity of diverse data and manage it via a virtual platform, through which it can be communicated in an easily understandable way, facilitating decisions. Ultimately, we like to say that Cassandra allows you to see what is there and foresee what the future might be, so that the path to the best possible future can be laid. Thank you very much. Over to you, Bob.
Thank you, Valerio and Mark.